Good morning, dear students. In today's lecture, we will talk about electrolytic cell and some important formulae associated with electrolytic cell. There is a basic difference between electrochemical cell and electrolytic cell. In electrochemical cell, the chemical energy is converted to electrical energy, or by the help of chemical reaction, we are producing current, electricity. But in electrolytic cell, it is just reverse. A chemical reaction occurs by the help of current, or we can say electricity. So here we can say that electrolytic cell is a device by the help of which electric current or electrical energy is converted to chemical energy. In electrochemical cell, the oxidation and reduction reaction takes place in different chamber, different halves. But here, the reduction and oxidation takes place in the same vessel. Electrochemical cell is spontaneous in nature, while electrolytic cell is non-spontaneous in nature. If we want to carry out a chemical reaction, then every time we have to supply energy in the form of electricity or electrical energy, electric current. So here is your simple setup of electrolytic cell. We are having an electrolytic vessel where we have placed two electrodes. They can be rectangular, they can be square, or they can be circular. Now, these electrodes are connected to the battery. The electrode which is connected to positive terminal of the battery is called anode, and the electrode which is connected to negative terminal of the battery is called your cathode. So, electrode connected to positive terminal of the battery, anode, and electrode connected to negative terminal of the battery, it's your cathode. And here in electrolytic vessel, we are taking electrolytic solution. Now, the formula used. So, whatever the rules or the formulae are associated with the metallic conductor are also applicable for electrolytic cell. If we talk about metallic conductor, then we say potential applied is equals to I into R. Current into resistance. So same formula is applicable here. Now if we talk about resistance of the metallic conductor. Now what is resistance? The obstruction to the flow of current is called resistance. And for metallic conductor, it was found that R is proportional to L by A. L, length of the metallic conductor, A, area of cross section. And when the sign of opposite is removed, we obtain a constant that is called rho. So R is written as R equals to rho into L by A. R equals to rho into L by A. Now what is rho? Rho is called resistivity, or it is called specific resistance. The unit of resistivity is ohm centimeter. Resistivity is the resistance offered by unit length conductor. So here if we talk about electrolytic cell, then these are the electrodes which are separated by distance L, It is constant. Having area of cross section as A. So whenever we talk about electrolytic cell, then value of L by A remains constant. The distance between the electrode and area of cross section of the electrode remains constant, and it is called cell constant. L by A is cell constant here, which can be represented by symbol G star. Now next one is your conductance, just inverse of resistance, just reciprocal of resistance. The east to the flow of current is called conductance. So here we can write G is equals to 1 by R. So formula becomes, put value of R. The formula becomes 1 by rho into A by L. Now inverse of resistivity or reciprocal of resistivity is called conductivity, which is represented by letter K. Sorry, kappa. It's kappa. It's the Roman symbol. And A by L is inverse of cell constant. So G will be equals to kappa divided by cell constant. Kappa is your conductivity, or it is called specific conductance, and cell constant is written as G star. Then comes the last term, that is molar conductivity. What is molar conductivity? Very simple. Suppose the electrodes are separated by unit distance, having area of cross section as unity, and this electrolytic cell contains 1 amp solution. Then the conductivity of 1 amp solution or 1 molar solution is called your molar conductivity, which is represented by this symbol, inverse Vn. It is found that molar conductivity is equals to kappa, that is your conductivity, into 1000 divided by C. C is your concentration, or it is called molarity. It means we can say that there is an inverse relationship between molar conductivity and concentration or molarity. So we can say here that if the concentration is increases or if the concentration is increased, then value of molar conductivity will decrease. If concentration is decreased, then value of molar conductivity will increase. So there is inverse relationship between concentration or molarity and concentration. Now about the unit. Unit of molar conductivity is Siemens centimeter square per mole. So here we have 3 important formulae. One is your resistance equals to rho into L by A. Second is your conductance, just inverse of resistance. And last is your molar conductivity. So that's all in this topic. In next lecture, we will see the variation of molar conductivity with concentration of the solution. Thank you. Have a nice day.